Hello, my name is Dan the Tutor, and today we're going to be talking about one of the biggest topics in all of pre-calculus. It's the unit circle. So the first thing I'm going to do is I will draw the unit circle for you. So first, let me get my coordinate axes like that. Actually, I'll make it bigger. That's good. And that's good. I need to draw a circle. Okay, and let me just move this circle so it's centered at the origin. Perfect. So here is the unit circle. Why is it called the unit circle? Because the unit circle has a radius of 1. And 1 is the most base number we can think of. So it's the unit circle. Now let me tell you where the degrees are in this circle, because I think we're all familiar with degrees more than radians, which is the other unit we're going to be introducing today. So 0 degrees starts at the positive x-axis. If you think of this as an xy axis, it shows up at the positive x-axis. And then we go counterclockwise around the circle. So there's 90 degrees, there's 180 degrees, and there's 270 degrees. And lastly, it even ends at 360. Notice 360 and 0 are at the same point. And anything over 360 just goes around the circle more times. So in other words, 720 would be 2 full circles. Now that I wrote all the angles in degrees, I'm now going to say that I don't want to use degrees anymore. Why not? Because degrees are an arbitrary number. What do you mean? Here's a question for you. Seriously think about this. Why are there 360 degrees in a circle? Where is the 360 number even coming from? It's an arbitrary number. It was probably invented by the Babylonians who used base 60. But 360 is a completely arbitrary number. Then what's the better unit? I'm sure you're asking. Radians is the better unit. What's a radian? Great question. A radian is equal to a radius. So for instance, with the unit circle, you already know the radian is 1. That's true. Why do we call them radians instead of radiuses or radii? I don't have a good answer for that, but we use radians a lot of the time in math, especially pre-calculus and especially calculus. Now, I'm just going to tell you what the radians are in this circle. We're going to start at 0 radians. Starts at the exact same place, the exact same thing. Now, here's a question. How many radians are there in a circle? Another way of asking that, how many radii are in a circle? And the answer, of course, is 2 pi. How do I know that? Because if I were to trace out this entire circle, that was horrible. If I were to trace out this entire circle, then that's the circumference, c. And how many radiuses are in a circumference? 2 pi. And that's why we have the equation circumference equals 2 pi r. So in other words, there are 2 pi radians in a circle. So in other words, 360 degrees translates to 2 pi radians. Then if I want to cut that in half to get to 180, that would be pi radians at 180. If I want to cut that in half again, I get to 90 degrees, which is pi over 2 radians. And then the other side here next to 270 would be 3 pi over 2 radians. Another way you can convert between degrees and radians, watch this. If, let's say, I have a 30-degree angle and I want to convert to radians, all I do is divide by 180 degrees and multiply by pi. The reason why this makes sense is because there are pi radians in 180 degrees. And when you divide this and plug it in your calculator, well, don't plug in pi because that's like 3.141592. It goes on forever, so just keep pi in the numerator. Don't reduce it into a decimal. And that will be pi over 6 radians, because 30 divided by 180 is 1/6. And so you can do that for any angle you want. So now let's make a table, and make this a big table because we are going to be filling in the rest of this with more stuff later on. But for now, I just want to make a table of degrees and radians. So we have 0 degrees. I'm going to add 30 degrees to it, 45 degrees, 60 degrees. Write this down too, everyone at home. 90 degrees, 180 degrees, 270 degrees, and last but not least, 360 degrees. And now here's all the corresponding radians, so we have it nice and easy for us. This will be 0, this will be pi over 6, then we got pi over 4, pi over 3, pi over 2, pi, 3 pi over 2, and 2 pi. Now, why do I care about 30, 45, and 60? Like, I get the other four, 0, 90, 180, 270, 360. I get those. Why do I need 30, 45, and 60? It's because those are, do you remember those special triangles you learned? The 30, 60, 90 triangle and the 45, 45, 90 triangle. Do you remember there was some special properties with them? That's why we care about those angles for the thing I'm about to say next. So the real reason we care about the unit circle is not because of the circle itself. Who cares about the circle? The reason it matters is because we're going to use it in SOHCAHTOA, sine, cosine, tangent. Let me show you what I mean. Let's draw a right triangle. I'm going to draw it on the top right part of my screen. And this, let's say, is a 45, 45, 90 triangle, just like this. And let's say the hypotenuse is 1, because unit circle, radius will be 1. And then the question is, what would the legs be? First of all, we know the legs will be equal because that's what they do for 45, 45, 90. The legs will be equal to each other. And if you remember, it's 1 over the square root of 2 for both of the legs. However, if you don't like square roots in the denominator, like my high school teachers did not like square roots in the denominator, this would be root 2 over 2 for both legs. And now around this triangle, let me draw my unit circle again. Just like that. Notice that this triangle is now on the unit circle. Every triangle you can possibly conceive of can potentially show up on the unit circle, as you can see here. Specifically every right triangle. I want to be very clear. All you need to do is draw the hypotenuse reaching one of the sides and then draw a line straight towards the x-axis and put a right angle. That's how you draw any of these triangles. But I'm going to erase this because it's getting cluttered. And let's just focus on the first triangle we drew. This one right here. So now the cool thing is, if you'd call it cool, I can find sine, cosine, and tangent right now of this angle right here, the center angle of my circle. Sine of 45 degrees is defined as opposite over hypotenuse. The opposite leg is root 2 over 2 divided by the hypotenuse, which is 1. So sine of 45 is root 2 over 2. And if you do the cosine, it will actually just be the exact same thing. It'll be root 2 over 2 because the legs are equal. And remember that tangent of 45 degrees, there's two ways you can think of it. The first way is you can say the opposite leg over the adjacent leg. Another way you can think of it is tangent is just sine over cosine. And these two things are identical. They'll cancel each other out. The tangent of 45 is just 1. And now here's another thing I want you to take away from this real quick. And that's the fact that the cosine is always going to equal the x value, which in this case was root 2 over 2 for my triangle. And the y value is always going to be the sine. The sine will always be our y value, which once again was root 2 over 2. So now with that in mind, you, the audience, can instantly tell me what the sine and cosine is of 0 degrees. Right here, 0 degrees, there's 0 degrees, or we'll say 0 radians, I don't care. What would the sine and cosine be of that? Well, since the cosine is the x value and the radius is 1, I instantly know the cosine of 0 degrees or 0 radians is going to be 1. Similarly, the sine being the y value, there is no y value, it's 0 for the y value. So sine of 0 is 0. And then once again, tangent of 0 degrees or 0 radians is the sine over the cosine. It'd be 0 over 1. The tangent of 0 is 0. That's pretty cool. Now let's consider another angle. Let's consider 90 degrees or pi over 2 radians, which points straight up. For this one, the cosine of, I'm going to use radians this time, pi over 2 radians, is going to be the x value, which I look at this line. Well, let me be more specific. I'm really looking at the coordinate point, and that's what I was looking in the last one too. This coordinate point right here that lies on the circle. Should have been more clear about that. But this coordinate point right here, the x value is 0 because it's on the x-axis, or I should say the y-axis. And the sine of pi over 2, that's going to be the y value, which again, this radius is 1. So the sine of pi over 2 is 1. And it's interesting when you get the tangent of pi over 2 because that, again, is going to be the sine over the cosine. You should be screaming at me right now because you can't divide by 0. And that's right, because it's undefined. And so you can potentially do this with any of the angles, any triangle on the unit circle. But which ones do we care about specifically and which ones are we going to memorize in pre-calculus? It's this chart right here, degrees and radians. So the other 3 columns I'm going to fill out here are sine, cosine, and tangent. And we are going to find the sine, cosine, and tangent of all the angles you see in front of us. So again, almost all of this is memorization. So sine of 0 is 0, cosine 0 is 1, tangent 0 is 0. Sine of pi over 6 will be 1/2, cosine will be root 3 over 2, and the tangent will be root 3 over 3. Again, I am not deriving this, I'm telling you to memorize it, and I would highly recommend copying this chart by hand because the more you write it, the more you're going to know it. Repetition is key. So pause the video frequently during this next minute and a half. Sine of pi over 4 will be root 2 over 2, so is the cosine, and the tangent is going to be 1. Sine of pi over 3 is going to be the mirror opposite of pi over 6, so root 3 over 2 for sine, 1/2 for cosine, and the tangent will be 1 over root 3 over 3, which turns out to be root 3 when you simplify. Then for 90 degrees, it will be 1 for sine, 0 for cosine, and undefined for the tangent. For pi, it's going to be 0, -1, and 0. To 70 degrees, that's like the lower position. It's going to be -1 for sine, 0 for cosine, and again undefined for tangent. And once we get back to 2 pi, we're back at the start. So the sine is going to be 0, cosine will be 1, and the tangent will be 0. Okay, and these are all the values you need to know for the unit circle. You don't have to memorize them today. Maybe you don't have to memorize them tomorrow, but at some point in the future, almost certainly you'll have to memorize these. So I encourage you to do it sooner rather than later. And then the final thing I'll say about the unit circle is that there's a lot more angles out there that we can memorize, but I'm going to choose not to. What do I mean by that? What about the angle 150 degrees? That's this angle right here, 150 degrees. Notice that the reference angle, if you remember what a reference angle is going to be 30 degrees because that's how you get to 180. It's 30 degrees away from 180. What would the sine, cosine, and tangent of 150 be? Well, I'll tell you, it's almost identical to the sine, cosine, and tangent of 30 degrees, except you just have to be careful with the positive or negative sign. So let me give you the answer first and then I'll explain it. The sine of 30 is 1/2, the cosine of 30 is root 3 over 2, and the tangent of 30 is root 3 over 3. But when I consider 150 degrees, it's going to be almost the exact same answer, except I have to look out for the sign. So I know sine will be positive, I know cosine will be negative, and I know tangent will also be negative. And these are our answers. Now you're asking a very good question right now. How did I know it was negative? Because all students take calculus. What does that mean? It's an acronym that I didn't come up with, someone did. But if you consider the unit circle and you remember the acronym, all students take calculus, the capital letter tells you what's positive in every quadrant. So in quadrant 1, everything's positive, sine, cosine, and tangent. In quadrant 2, only the sine is positive, everything else is negative. In quadrant 3, the tangent is positive, everything else is negative. And then quadrant 4, only the cosine is positive, everything else is negative. So that acronym, all students take calculus, is meant to remind you what's positive in each region. And remember that 150 degrees was this right here. That was quadrant 2. That's why only the sine was positive. We'll look at one more example. Let's say I want to look at 315 degrees, which is the same thing as 7 pi over 4 in case you're curious in radians. And again, I want to know the sine, cosine, and tangent of this angle. So where is 315 degrees? I know that's going to be right here, and I know the reference angle is 45 degrees. How did I know that? Because 360 degrees, the angle that it's closest to, minus 315 degrees, that's how you get 45 degrees. So I know my reference angle is 45 degrees. That means I'm going to treat it like a 45 degree angle. And I know it's in quadrant 4, so I know only cosine is positive, everything else is going to be negative. So the cool thing is I get to treat it like a 45 degree angle. I know the sine of 45 is root 2 over 2, and since only cosine is positive, I know it's negative. Cosine will also be root 2 over 2, except it's positive because cosine's positive. And then tangent is going to be 1, but negative because of the fact that it's in quadrant 4. And you can answer problems like this in 2 minutes, just like I did. But it's going to take a lot of memorization, especially for this table right here. I highly recommend memorizing this entire table. And so that's a great introduction to the unit circle. Thank you all for watching. If you have any questions, please comment below. And I will see you in the next video. Take care. Bye-bye.